So alpha is 0.05. We know it's a two-tailed test from the beginning. We just figured out we have to use t-scores. My degrees of freedom are going to be 101 minus 1, so they're 100. Can you take a minute and figure out what the t-score is going to be? Alpha 0.05, two-tailed test, 100 degrees of freedom. Yeah, 1.98. So negative 1984, positive 1984. So just the t-score chart does not have any negatives on it. We're the humans. We have to know when it has to be negative and positive. In this case, it's got to be both because it's a two-tailed test. So if I get a t-star that is greater than 1.94 or less than negative 1.94, that means we can reject the null, because the null is the dude who thinks it's in the middle. He thinks it's equal to 23, so he thinks the sample should show up in here. If I get a sample out here somewhere, that's evidence that the ha is right. That's evidence that the ho is wrong. Okay. Which is probably not a phrase you thought you'd hear this semester at all. So x bar, so somebody help me out. What's x bar? From our sample, what's x bar? 22.1. What's s? 4.25. So I need the new, so n is 101. So what's the new standard deviation? No, 1 point, Joe. Sorry, say it again. 0.4229, that sounds about right. So I'll just do 423. It's almost 425 divided by 10, so it kind of makes sense. And again, step part D, this fourth step is like the most, we've been doing this a lot, right? It's the same thing, it doesn't really change. Thankfully, the formula is the same. It's our data minus the supposed middle divided by the new standard deviation. I think there's like 2.2 something. Yeah. 2.13?
Yeah, 1.3.
Gotcha. So did we make it far enough away? Yeah. Hell yeah, we're right here. So that means we can do what we said here. We can reject the null, support the ha. If we didn't make it in there, I should have made this come out to be not working. If we didn't make it in there, then we just say fail to reject the null, fail to support the ha. But we didn't fail, we got in there. Which one was my claim this time? The ha is my claim. So I want to use this language, not that language. I want my conclusion to talk about the claim. That kind of makes sense. I want to know, did our claim work or not? Did we find evidence for it or not? So we made it. We have found sufficient evidence to support the claim that plagiarize. The assembly time for Ford Focus has changed. I really want this just to make sense, in your gut. There was the old one was 23. We found a sample that was far enough away from that to say it looks like it actually isn't that anymore. Is there a chance we're wrong? Yes. What's the probability we're wrong? 5%. Yeah. Roughly. It's not perfect, but it's pretty close. Okay. So I know. And yeah, let me go ahead and talk about types of error real quick, because I said I would. I'll just tell you the main idea of it, and then next time we'll do some more concrete examples. But didn't we just reject the null? Right? Didn't we just say this guy looks to be wrong, correct? When would we be wrong about that? If we reject what this guy says, when would we be wrong? If the mean really is 23, yeah? We don't know what the shit the mean is. And we just admitted there's a chance we're wrong. So even if we do everything perfect, we might be wrong because there's this chance that we're wrong. It's all based on samples. So the type 1 error, and to make it all official, they use a Roman numeral. Type 1 error is reject a true null. So whatever the null says is true, but we think it isn't. So that's an error, it's a mistake. That doesn't mean we calculated something wrong, it's just built in, it's statistics. It's the most honest freaking math there is. It's like, hey, you did everything perfect, but you might be wrong still. And now you see, that's why people don't like statistics. They want it to be perfect. And I'm like, no, it's just like trying to predict lottery numbers. You ain't gonna do it. So at type 2, the only two things we can really do are reject the null or fail to reject the null. So type 2 error would be to fail to reject a false null. So the errors we make are rejecting something that's actually true, that's a mistake, or not rejecting something that isn't true, that's a mistake also. Those are the only two types of errors that can be made. This one is roughly related to alpha. The error for this one is alpha. The error for this one is harder to get. It's a little more computation. And believe it or not, it has a symbol beta, A, B. Make beta better. Beta. Okay. Oh, shit. All right. I think that's plenty. So we got the other side of that worksheet we'll do next time. I'll have the quizzes graded next time. We're just going to keep doing some more examples of hypothesis tests. We got to get into percentages, how to test percentages. And if there's enough time, I like to do this thing. There's not a ton of us, but I like to do this thing where I have you guys test each other to see if you have ESP. And we use hypothesis tests. One semester I had this girl, she showed evidence she had it, and then I tested her directly, and then she showed evidence again. I'm like, I gotta wear a tinfoil hat when you're taking a test so you don't read my mind. Shit. But of course, again, there's a probability that you're wrong, but they kind of freak me out. So we'll see. If we have enough time, we'll try to do that. It's kind of nifty.